Hi, good morning, good evening, and good afternoon, because I think people they have joined from a different time zone. My name is Praveen. I have 12 years of experience in networking, and I am working as a seasonal trainer as well. So I'm the instructor for this particular course. This is a Wireshark Basic to Advanced training. So I hope you guys can see my screen. So these are all the list of topics. So this is the course content we are going to cover. So it's about, I would say the training hours would be 40 to 45 hours. So you can reach out to Mushkan for the fees, right? So it's an USD 200 USD, and it is 12,000 Indian rupees. So this is the course content we are going to discuss. So we all know people are from a different background. Maybe there will be students, there are working professionals. So we want to focus on everyone. So we will go from the scratch. So we will discuss about the basics of networking, what is OSI, TCP, IP model. But you may think, I know this, why I want to join this training. That's something we are different from others. So we are not going to teach you just the theory. So I would say mostly the session would be followed in the same way for every session. It's like that. So it will be 80% of practical and 20% of theory, right? So we mostly stick with the Wireshark. We'll do a whiteboard explanation parallelly with that. So we are not going to discuss much on theory. We are going to spend more time, get your hands dirty with your practical sessions. So that's the whole objective of this training. So once you finish this training, even you can be a tech or you can be an architect and you can be a student, you will get the fundamental is the key for everything. That's what we believe in this training, right? So if you're very good with your fundamentals, obviously you will troubleshoot better. So even AI comes in, even you can do a scripting. If you don't understand the protocols, how it works, you can't find a problem, right? So you can see there are some extraordinary people, they'll always be there. You have seen people, they work for TAC. The way how they troubleshoot is different. That's something inspired me, 4 5 years back. So how can they dig deeper into a specific problem? That's something most of us we lack in the beginning, right? So I'll answer all these questions. Marcus, I will give you a session there where we will discuss about your questions. Now let's continue. You mark your questions and I'll answer your question. Everyone is like that. You can note down your questions. You can ask me when there is a Q&A session in 15 20 minutes. We'll have a break in the middle. We will answer your queries and then we will continue. So the tag they do a troubleshooting better. So always why is those set of people they do troubleshooting better than us, right? So even we know TTL, so where exactly it applies, where I have to find a problem, that makes a difference, right? So I want to explain you a very simple scenario where exactly the Wireshark helps. So we were working with the problem. We had some problem with the Zscaler traffic. The traffic is not going to the Zscaler. So the attack came in. He went into the internet router. He just checked the TTL and he said the TTL is not incrementing. So there is a problem with your routing. So you just imagine how quickly he found there is a problem with the routing. So you may be checking your BGP, you may be checking your route tables, whatnot, right? But it is just one straight away he went and he found it's a problem with that. So in the same way, so here we are going in deep about every single layer. So say take for example this lab. So you will see what is the use of ARP. You may know ARP, but what is the use of ARP with Wireshark, right? So we will have a demo session there. We will see actually how Wireshark helps you to figure out. Normally you do an ARP, you do a troubleshooting with ARP, but how the Wireshark stands out to find a problem with ARP. So it goes on like that, right? So the ARP is a very basic of it. So we have a lab for ARP scenario. Whatever we are learning, we are going to go deep, well deep into the all kind of ARP flavors, different ARP types, and then we will do a lab for it. Then we'll go to the layer two, and using the layer two, how I'm going to troubleshoot a problem. That makes a difference, right? Even in the demo, I'll show you how, with the help of layer two, how you will find a problem. And then we will talk about the basic IP addressing. What is private, public IP, subnetting? We know that. And then there is ICMP messages. There are different type of ICMP messages. We'll go through every single ICMP message with Wireshark. We'll compare the type and code of it. What is the TCP based ICMP? What is UDP based? What is trace route? How you can use the trace route to troubleshoot a problem, right? So we have a lab for it. For everything, whatever we learn, we have a lab for it. And the main thing, right? When you talk about the Wireshark and every application, so once you mostly figure out your routing and switching problems in your layer two and layer three, and then we will go deep into a layer four problem. So inside the TCP, there are different flags. So when you talk about TCP, you have congestion control, you have a TCP flags, you have TCP window problems. This helps you to figure out the most critical problem in the network. It comes is the network slowness, right? So we have a lot of use case scenarios where we can figure out, we can practice how I can troubleshoot a problem. Is it a problem with the latency? Is it a problem with the jitter? Or is it a problem with the window scaling, right? And what is MTU? What is maximum segment size? What are the different types of TCP flags? A guy, he asked me a question about reset. What is reset? Why reset is happening? What is retransmission? TCP retransmission. So how I can find out who's doing the retransmission? What is the purpose of retransmission? And how I'm going to figure out with Wireshark, right? So we'll see what is flow control, what is selective acknowledgements, what is TCP timers, and then what is the difference between TCP and UDP, and the most commonly used ports, known ports and unknown ports in TCP and UDP. So we have a discovery lab for it. So we'll take a stream. We will find out all the problems, whatever we discussed here. And then we have a separate lab for your DNS, right? So when there is a problem with the DNS, is it because of a DNS slowness or the DNS server is down? How do I figure out that, right? So what are the different types of queries the DNS is using it? And we have a lab for DHCP. So you may think DHCP is just DORA process. It's not, right? So even you have DHCP options for wireless. So you have DHCP options for VoIP. So where exactly I can go and find those DHCP options there? And we have a DHCP relay lab where we usually the enterprise is designed in such a way that they will not have their individual DHCP servers in one place, right? They have a DHCP server as a centralized DHCP server in their data center. So we use something like a DHCP relay agent where we use an IP helper address. It reaches to the DHCP server and you get your IP back to your subnets. So we have a lab for it. And in the switching, we will see what is VLANs, what is inter-VLAN communication, everything with packets, not with configurations. As I said, this course is more focused on your Wireshark, right? Not with configurations, because configuration everybody knows how to configure. If I go and do a configuration for a VLAN, I can do that. If I connect a firewall there and I create a VLAN for a firewall, my IP communication happens there. So that's not the whole point. The whole point is how I'm going to figure out a problem, how I can make myself better in troubleshooting with packets, how I can figure out a problem very quickly, how logically I can find a problem with Wireshark, right? And we will talk about the routings, right? So the routing, when it comes, I would say the static routings everybody is doing, right? In even the firewall, you do static routing. Even in the load balancers, you do static routing. But the big piece of the routing and switching that comes in play is when you do a lot with your OSPF and BGP. So we'll go deeper into OSPF packets and different areas, multi-area OSPF, not so stubby area, all those area types we are going to discuss. And we are going to see every single LSA types inside, how it is being exchanged, right? Because even in Palo Alto firewalls, I have seen my friends, they say they're using OSPF, they're using BGP for it. So you will see BGP and OSPF is a very dedicated topic we are going to discuss about in a very deep level with Wireshark and configurations. You can definitely, hone your skills in BGP and OSPF
Hi,
while learning this.
Parveen. Actually, your Outlook window is shown in your screen. Have you shared any PPT or anything? Because currently your Outlook window. So please check once.
Is it? I'm sharing my course content. You can't see that the Excel sheet with course content.
Window is showing on your screen. Can you please share it again?
So how about now? Muskan, how about now? Can you see my
Same,
screen now?
it's your Outlook window.
Still Outlook window? Is it same thing for
Yes.
everyone?
Can you
Yes, yes.
What do you
Yes,
guys see? What do you
yes,
guys
yeah.
Your
see?
Outlook,
Just
your
your
Outlook
Outlook,
Outlook.
we are
window,
seeing.
Outlook
We are
window.
not
Yes,
seeing
we
From
are
any.
from
seeing.
from the
Outlook
time
window.
you started, we've just been seeing the
Just
Outlook
been seeing Outlook
page.
there.
We
We are
haven't
not seeing
seen
any of the
anything.
course outline.
Okay,
Yeah.
I'll try one more
We
time.
were lost, and the chat is also disabled. Can you enable the chat, please?
Yeah, now it's perfect.
Now we can see.
Okay, I know there's a glitch. So what is that? You guys can type, right? You can't chat?
No.
Yes. Chat is also disabled.
Can chat with the admin only.
Okay.
Yeah, just enable the chat and just enable the speaking thing. Because we are not able to speak, we are neither able to send any chat messages. So that only makes it a one-way kind of a thing. You're only seeing the Outlook all this time.
Okay, got you.
Thank
Uh, so I hope you guys can see my screen now, yeah? So this is the total hours is 40 to 45 hours of training, and the name of the training is Wireshark Basic to Advanced Training. And this is the fees. This is US dollars is 200 US dollars, and the Indian rupees is 12,000. So you can reach out to Muskan. That is given in your, your WhatsApp poster, right? So you can reach out to her. Yeah. And I'm going to unmute everyone because this is a problem, yeah, because there's a lot of background noise coming in. So Muskan will enable a chat so you guys can chat and reach out to me. And after 15 minutes, I will unmute everyone so that you can ask your question. You can, in the meantime, you can mark your questions. You guys know the difficulty of. I am ready to do that, but if you can see a lot of background noise coming in, people they don't
That
mute.
is fine. That is fine. You can mute
Yeah,
us whenever
yeah,
required. You can unmute. I think that is
yeah.
better.
You can raise your hands. Maybe in the meantime, I will try to unmute and talk to you guys. Yeah. So it's as I said, 80% practical and 20% theory. And sorry for that. I mean, I don't know. There was some glitch in opening this. Um, so this is the basic of networking. We cover the basic of networking because we focus on students as well as working professionals. So we go deep into the layers with the Wireshark. So that is the difference I'm talking about. So everybody knows the OSI model, but we will go into the every layer and we will see the options of every layer. And the same thing we will practice in the lab. So where it helps, we may think this is all something theory. Why do I want to know about this? Definitely not. Because if there is some problem with that, you may be troubleshooting your problem with your firewall. But what if your base communication is not happening? If there is no ARP communication is not happening, and if your SVI is down, how you're going to figure out a problem? So the base is very important. So if you make your foundation stronger, then you can troubleshoot better. So that's the whole point of designing the whole whole content, because there is a separate team in-house. They prepared this document based on what's the best we can do and how we can actually build up the foundation with the students, because where we struggle. So they did a proper analysis and they have come up with this topics. So we will discuss about ARP, how it works in different subnet and what is the different flavors of ARP, and we will do the use case for the same. And we will go deep into the Ethernet frames, how it works, right? This is all packet level I'm talking about, and we have an use case scenarios that makes a difference. So it is not just you're going to learn a ARP and you will see the packets. It's not like that. We will replicate a scenario where if there is a ARP is failing, how we are going to figure out using the Wireshark. So we are going to do that. And in the Ethernet frames, we are going to learn about the MAC address, what is source and destination MAC address. We know that. But how I am going to use this MAC address to figure out the problem? Say, for example, if your DHCP request is coming from switch A, and if it is coming to your core switch, and what can I see that MAC address in my core switch? You can see that definitely in MAC table. But can you see that DHCP discover messages, all this your door of packets? You can't see that. You can do that in your debugging on that particular switch, but is it actually reaching out to the core and it's going back to your centralized centralized DHCP server or not? That's something we will focus on, and we'll see where exactly the packet is getting blocked and how we are going to figure out that using Wireshark. Yeah. And we know this is a basic of IPv4 addressing schema, and we will learn about that. And this is the most important thing, right? When we go for the layer 3 header, so most of the problems happens with the fragmentation. If there is too much of fragmentation is happening, or apparently you will face a slowness problem. And if you establish a connection to a device, if there is a problem with your OSPF, I have seen in a scenario where your MTU, there is a different MTU mismatch between those two devices, your neighborship will not come up. But how this Wireshark is going to show me the MTU values, which header I am going to see that, right? And then we will see the IP options, what are the different IP options, and how this layer 2 address and layer 3 addresses changes, and how this packet flows through the switch, routers, and firewall. So we will have a firewall, switch, and router, and we will see how this packet is flowing through in the packets. Along with the packets, we're going to see that. And if you ping, you will see request timed out, destination not reachable, host unreachable. So we will do all those use cases in the lab with the different ICMP options. And we will use a traceroute, how traceroute helps me to figure out a problem, right? Even if something is blocked in the firewall, is it my packet is properly routed from A to D? So BC can be a firewall, BC can be a proxy. So how do I find out if there is a device in the middle which is blocking my packet? So we'll see this TCP errors, traceroute errors in using your Wireshark. We'll do that. And this is a very dedicated topic, and this is the most predominant topic we are going to discuss. We are going deep about the analogy of TCP fields, and we'll go with congestion control. What is explicit congestion notification? And then we will discuss about the TCP flags, what is MTU, what is TCP retransmission, what is fast retransmission, what is selective acknowledgements, what is TCP timers, everything in packets, right? Not in a theory, as I said. So we have a lab with that. So we use a TCP UDP streams and flow graphs with Wireshark. We will see that. And as I said, the DNS is very important for most of the problem. If your DNS is not working, apparently your URL is going to, your URL will never work, right? So you're going to figure out how I'm going to find out a problem with the DNS. If there is a problem with if there is a slowness in DNS, how using a DNS timers I'm going to figure out problem, how I'm going to troubleshoot a problem with DNS. So all this, we have a DNS lab, a dedicated lab for it. So we are going to see all these differences, and we'll see what is DNS TTL. And also, I will help you to create individual profiles for different problems, right? Very quickly, you can go and real quick, you can go ahead and just click a button and you can figure out a problem. But you have to make a filter of it and you have to understand the fundamentals of it. So that's something we will focus on. And in the DHCP, as I said, it is also used for VoIP communication. It is used for wireless. So we'll see different DHCP options, where to find, and we will see how this IP helper address is used and what I should see in the IP helper address. And what if I don't get an IP address for a specific subnet, where exactly I can go and troubleshoot a problem using a Wireshark? What are all the key headers I should look for if there is a problem? So we will see that in the DHCP relay lab. So from here, I'm going to pause for a moment. And if there is any questions, you guys can ask me now.
Hi, Praveen. Pawan here.
Pawan.
Want to ask you about the lab. So, do we have to create our own lab, or will there be any access provided?
No,
What?
actually, for this, you need a very simple lab. I mean, as I said, a 16 GB RAM is more than sufficient. You will be play with a couple of routers, 4, 5 routers maximum. That's it. So you're going to do everything with 4, 5 routers and maybe one firewall and not more than 5 nodes in a topology. So we
Okay,
will
but
just work everything within 4 to 5 devices.
okay. The thing is that I only have my office laptop, and I don't think I can install any means these software like VMware. So means if I take outside rental lab, do I need a licensed firewall, or the free version will be okay, like in Palo Alto?
Yo, what is your question? Can you repeat one more time?
I'm saying that I have my office laptop, so I will not be able to means create the VMware lab there. So if I take out means buy any or rental lab access, so there in the device, do I need any licensed device like licensed Palo Alto, or the
No, no, no,
like
no,
the
no, no, no. I mean, I there is a maybe very cheap price. You will get maybe 2000 Indian rupees. You will get a rental lab, right? So maybe I think if you take a rental for 1 month, that's sufficient to practice everything. Within a month, you can practice everything. The one more month, you can keep it yourself. You can use your same office laptop to just use your Wireshark. It's more than sufficient to do that. So I know most of the students, they may have this question in their mind. So for that, I'm going to show you at the end of the session. We have a dedicated session where we troubleshoot a problem, network slowness, and I'll show you how you can do that. That's very easily you can do that.
sure,
It's
sure.
just an, I think you might be using your iPerf tool, right? But having a lab is definitely needed. I'm not telling you you should not have a lab. You should have a lab, but it's a very small lab is fine. 5 devices. That's something you can use your personal computer or something to do that. I think you can do that with EVNG or GNS is also fine for it.
Yeah, hi,
Sure.
hi Praveen. Together here. Just for the benefit of everyone, the one sheet that you were sharing, which had the outline and the topics, can you share that in the chat, please? Because
Guys,
as for
I
our
mean,
reference.
yeah, I mean, guys who are all not talking, please be on mute because we couldn't talk. Yeah. What is that? What is that, Robinson? You said what do you want in the document?
I'm asking if you can share the document that you were going through, which had the topics for the reference.
Yeah, we will give the document. I mean, the course content is something you're talking about.
Yeah, the screen that you were sharing, right?
Yeah,
It was
yeah.
an Excel copy. If you can share that, please.
Yeah, sure. I will ask Muskan to share this document, or maybe if I have an option to share, I will share.
Or if you can put it in the chat in the common one, so we can have it look at this
Yeah,
as well. Yeah.
sure.
Thank you.
Yeah. Other than anybody has questions.
And timings, please. Timings for this one.
Timing is 40 to 45 hours.
No. Weekend batch timings. I mean,
We can
IST
batch
hours.
timings as something Muskan will talk about that, the batch timings. Mostly it would be in the morning,
Oh, okay.
around 12, 10 to 12.
Hmm.
Yeah.
Okay.
10 a.m. to 12 a.m. IST. 12 p.m. Sorry. 10 a.m. to 12 p.m. IST.
Is there any chance to move to evening? I mean,
You can talk to Mushkan. We'll decide
oh,
about that, but this is mostly in the morning, 10 a.m. to 12. But you have a recorded sessions. You can watch the
mhm.
recordings and you can practice for sure.
Okay.
If you can't make it on every week and every class, you have your recording session always handy with you.
Yeah. Okay, bro. Thank you.
Yeah.
Praveen, you
Thank
mean
you.
like,
Thank you.
hi Praveen, you mean like we can record the session or you will be providing us the recording session?
No. We will provide the recording sessions for you. We have a
Oh,
separate portal for you. You
yes.
will get access to the portal, so you can watch anywhere, anytime using your mobile or your laptop, and you can
Okay.
practice. Yeah.
Is there any FI configuration here, like in this lab for packet testing?
No, there is
FI.
a dedicated training with this the trainer. So we have a training for FI, a dedicated training for FI. But here, no, we are not using FI here.
Okay.
Yes, Mr. Praveen, this is Ijaz here.
Yeah. Yeah.
Yes, I would like to ask you regarding, do you have any training for especially the Fortinet training?
I think Mushkan will answer that. We have a plans to do that, but I don't think we have it. We have it ready now. Maybe in the
Okay.
future. Yeah.
Okay, thank you.
Is any other questions, or else we can jump back to the session? Okay, so if there is no further questions, I'm going to mute everyone and let's continue the session there. And I hope you guys can still see my screen, right? You guys can see my screen, right?
Yes.
Mm,
Not yet. Not yet.
Not
no.
How about now? Not it.
Not it.
No, still not.
I think why it is keep breaking. Okay. How about now? I think you guys can see my screen, right?
Yeah. We can see
Yes.
that Excel
Now.
sheet.
Now.
Okay. Got it. So I'll mute now. Thank you. So you guys can chat or you can raise your hands so that I would know what is the problem. Yeah. So followed by that, we will go into deep into the switching part. What is the difference between ARP table, CAM table, and then what is the LACP, link aggregation protocol. But with Wireshark, every packet, we will see that. We will do a lot of troubleshooting with that, the scenarios. It's not just a configuration on that. And we have separate two sessions dedicated for OSPF and BGP, wherein the BGP and OSPF. And OSPF people, they do normal OSPF, but we focus on multi-area OSPF and we see all the LSA packets right on the router as well as the Wireshark, and we'll understand about how exactly the multi-area OSPF works. Right, and we will discuss about all these areas, all the special areas in OSPF, along with LSA types, and how do you troubleshoot a problem when there is a problem with your OSPF. All the possibilities we will cover in the session. And BGP, as I said, I mean, some people they are still using it in the firewalls as well as in the data centers. That is the key protocol they use for data centers. And sometimes if they are using the firewall as the internet gateways, they use BGP. So most people I have seen they struggle with what is the difference between eBGP and iBGP. It's a very basic thing, but I have seen people, they struggle with that, but we will go through all the BGP attributes, the most widely used attributes, AS path prepending, and we will focus on weight attribute. We'll focus on local preference attribute. So this is all something they mostly used for traffic engineering in BGP. So we're going to cover that in the BGP. And the other thing is we will then comes to your firewall. So in the firewall, we will see what is stateful, stateless firewalls, and how to create the zones in the firewall. Then we will do a NATing, and this is all we are using the Palo Alto for doing all this. So what are the different types of NAT? Source NAT, destination NATs. We know that source is used for outbound traffic, destination for inbound traffic. When you host something like your web browsers, sorry, your web servers, you'll be using your destination NAT. How I can use the Wireshark to figure out a problem if there is a problem with a NAT. And we will see what is NAT unidirectional, bidirectional, and how this packet flows through a PAD device, right? How your IP is changed and what you see in the Wireshark when the packet is changing. So you can compare side by side and you can do your troubleshooting. You can elevate your troubleshooting with that. Then we'll see the packet flow through the firewall for different protocols, TCP, UDP, ICMP through firewalls. Then what is TCP sequence check and what is a TCP SYN check, how to do that, and we'll do an FTP through a firewall. Then we create an ACLs, those policy-based VPNs to allow your VPNs through firewalls. And we will see what is route-based VPN, policy-based VPN. For this, we will be using the Cisco device to differentiate your route-based VPN and policy-based VPN. And we will see all your IKE messages, IKE phase 1, phase 2, and all your 6 messages. Before encryption, there will be 4 messages in your main mode. You will see all those packets using the Wireshark. And we'll go deep into the IPsec because IPsec is the key to establish most of the connection, right? When you have your data center, if you want to establish your connection with your cloud. So we will go deep into the phase 1 and phase 2, what is an encryptions and all the details of all the 6 messages. Haggle parameters, we will see that what is the difference between main mode and aggressive mode. So the 6 messages being squeezed into 3 messages there. And what is perfect forward secrecy? What is the IPsec modes? What is the tunnel mode, transparent mode? So what is AH and ESP, right? AH provides only the hash, but ESP, it does an encryption and hash. So how do I see the port number 4500 there? So it's used for NAT-T, and the IPsec uses 500. So how I'm going to troubleshoot those problems. So we'll be doing an overlapping subnets by creating the VRF on both end, and we are going to do an overlapping subnet. So both subnets is used in point A and point B routers, and we will do the troubleshooting scenarios there. And we will troubleshoot a very deep level of phase 1, the message 1 to 6. If either one of those messages fails in the middle, how I'm going to find that exactly in the Wireshark. So overlapping subnet scenario using the VPN and then your private IP to private IP, setting up your VPNs on both ends, right? So and the NAT traversal problems, NAT-T we will be doing. And the final piece is your SSL, because you know everything, right? Right, even your VPN, the key encryption hash, KEH, key encryption hash is a move 3 base 3 primary parameters when you establish a connection. So in the same way in the SSL, how I am going to troubleshoot a problem if there is some problem with the certificate. If the certificate is expired, if there is an unknown CA is found, so how do I find that? So even you have your certificate, but if you don't have your root CA, so apparently you can't establish your connection with that particular server, isn't it? So we are going to check all this. So where exactly I should see the record layer, where I can see those warning messages, I can figure out where the problem is. And what is the different types of warning, alerts, fatal alerts. Then common certificate problems is a issue with the issuer, or it is an expired certificate, it's a common name mismatch, is it a certificate revocation problem, and we will see what is traffic selector, proxy IDs, and what are the different types of traffic selectors we are going to use there when we use a proxy IDs. So this is the whole content of this course. So I'll unmute, and you guys can ask a question. Then we'll jump back to a quick demo. There I'll explain the network slowness. How do we use the Wireshark to figure out that problem? And along with this, it is a bonus. On top of this, for some simulation, we will be also using the Nmap tool. So we'll be using a ZenMap, that is the GUI based Nmap. So in Windows, you can use this ZenMap. If you have Linux, you can use the same set of commands. I'll show you that you can use the same command on your CLI. The only key difference is you have your GUI interface in Windows to run those commands, whereas in Linux, you can run the CLI commands in Linux or Unix boxes. So now let me give an unmute permission for everyone. So if you have any questions with this so far, you can ask. And 1 minute, yeah, 1 minute. And
This is Hemu.
yeah,
Praveen.
Hi Hemu.
This is Hemu. You can just complete your session and take the Q&A after the session.
Oh, is it? Okay, Hemu. No, actually they said in the middle they have some questions in the middle.
No, just take
So
take all the questions in the Q&A session, not now.
Got you. Okay. Okay, Hemu, sure. Yeah.
Muskan, please make me co-host.
Oh, yes, sir. Just making.
So now let's jump back to the troubleshooting scenario. So I'll show you the basic of how Wireshark looks and what we are going to troubleshoot in this session. So we are going to find the network slowness. Before that, let me fire up the Wireshark. So here, when I fire up the Wireshark, so I am using my Wi-Fi connection. You guys this is my secondary monitor, so you can't see the actual connection here. So I'm connected to a Wi-Fi. So when I fire up the Wireshark, I have an option to choose the interfaces. So these are all the connected interfaces in my laptop. So I'm going to capture all the traffic on my Wi-Fi now. So I have to click on my Wi-Fi, and you can see the little graph that's running here. So there's the actual traffic is going in all these three interfaces, but I am interested in Wi-Fi interface. So I'm going to double click. So you can see all my packets, all the communication, whatever happening in my wireless, you can see all the traffic here. Right. So I'm going to pass this connection. And then I'm going to do a quick network testing, right? Network speed test. So what we generally do, we do speed test.net, and you will do that. But actually in the enterprises, we don't do that, right? Because it just gives you the what is the speed, but you don't know what is the packets and how do I see the packet level information there. So for that, I'm going to use a tool called iperf. I'm going to run the tool iperf here. So I can simultaneously see my traffic in the Wireshark. So I'm going to see, so we are going to focus only on Wireshark here, how Wireshark is going to interpret that. So what I'm doing here is, so this is a type of command I'm going to run. This is in my exe file. This is an exe file I'm going to run in my command prompt. And this is the public facing iperf server. So this is the port number 5202 destination port. And I'm going to run 10 parallel connection. So that is the meaning of this. So iperf-c is a client. I'm running this as a client mode. So this is iperf client. My computer is a client. So this is my destination, the server, and this is the destination port 5202, and this is the parallel connection. So I'm going to run 10 parallel connection at the same time. So this is the command I'm going to run in my command prompt there, and simultaneously I'm going to capture the packet here. So I'm going to start my capture. And let me stop this. So I'm going to look for TCP packet first. So you can see a little yellow button icon in the corner of your Wireshark. You have to click on it. You can expand in the very top, and you can apply as a filter. Right click, apply as a filter. I'll repeat one more time. So I have to click on this button, yellow button in the left corner, bottom left corner on my Wireshark. Click on it. You can see the whole insight of what is happening in my connection. So I'm going to the top, the warning message. So I'm going to right click, apply as a filter, select it. And if you see, so this is the destination, right? This is the destination IPEV server, that is the Skype pingonline.net. The pingonline.net, if I resolve this, I'll get this IP address. So right away, when I click on this yellow button and I clicked on it and I saw the reset. So what is the meaning of this? So let me take my digital pen here. So this is my client, and my IP address is 192.168.0.9. This is my client, and the request is going here. This is my IPEV server. We are doing an IPEV. It is 192. Sorry. So the IPEV server is 51.158.1.21, right? And when we say TCP, it's a three-way handshake. So the client is going to send a SYN. I should receive a SYN-ACK back. And again, it will send an ACK message back. This is called three-way handshake, right? So let's see here. So in the broken packet, I did an IPEV. What is the information I can see from layer 1 to layer 2? So I'm going to the layer 4. The source port is 5201 because the source is 51.158.1.21. That is your IPEV server. So we are trying to establish a connection over 5201. You can see that. So this is the source 5201. That is the IPEV server is responding back to my destination. This is my computer. This is my Wi-Fi IP address I got, and this is the protocol I'm using it. And it says it's a reset. So how do I find it is a reset connection? I have to open my flag. And if I see that, and this is called as a reset. Who did a reset? The source did a reset. So it is not ready to establish a connection to my computer. It might be busy at this time. But does it mean that I don't have a routing? I definitely have a routing, right? So how do I check that? I have to go to my layer 3 header, IP header. I can see the TTL is decremented to 47. So by just looking at this, so there is a 3 type of different TTL when it comes for your routing. So one is 128, 64, and 255. So it's based on the operating system. Some operating system, they might be using 255. Cisco devices, they use 255. Linux, mostly they use 64. So the destination, based on the destination packet, I can see my TTL is decremented to 47. So how exactly the TTL works? So you have devices like this connected, right? So the maximum hop to reach any destination is 30 maximum hops. So what happens here? I have a connection in the middle. There is an ISP. They are connecting. We establish a connection, right? And this TCP is a peer-to-peer protocol, isn't it? So this is my source and this is my destination. So this is P2P connection, right? And the protocol used is TCP. So here, if I have a proper routing, so for every hop, there will be a TTL decrement. So that gives a TTL. So that's a whole different session we have in the class. But the whole point is I have a routing, but this client is trying to establish a connection to the destination, but the connection is not established because it resets the connection. By looking at this Wireshark output, what can I find? The destination is resetting the connection. I mean, from my source, I'm telling. So here the source is resets its connection. This is my computer. So it is not ready to establish a connection. So if I go to TCP now, if I go to the conversation, this is the whole conversation, and this packet is in the middle of the packet when it did a reset. So if you see this is my source, my computer. It tries to establish a connection. The first packet is a SYN packet. You can go to the flag and you can see right here. This is a SYN packet sent by source. The source 192.168.0.9. You can see this. This is my port number, right? This is the port number of the source, my computer, and it is trying to establish a connection on 5201. And this is a SYN packet. For that, I got a SYN-ACK back. So what is the source port number now? It's changed to 5201 because now the source is the iPerf, and my destination is my client. So this is server and this is the client. So there is the port has been swapped. I mean, this is 5201. It comes from the 5201, goes to 28855. It's a random port. This is called a SYN-ACK. So how do I check that? It's a SYN-ACK packet. I have to click on this packet and I have to open up the flags, and you can see both my ACK and SYN, both are marked here as one. SYN-ACK, for the SYN-ACK, the client is going to send an ACK packet back again. So you can see only the ACK packet here. So my three-way handshake is fine. So once you have your routing, only then your three-way handshake happens, isn't it? Because this is your client and this is a server. So we know some kind of IP routing is happening in the middle. If I don't have a routing, how can I expect the layer 4 to work? Because layer 4 is your TCP. So this proves that I have a routing, but the reset is happening just because of layer 4 problem right away. So I can go here. So immediately you can go and find who is doing a reset. The reset is done by the server 51.158.1.21. See, again, this client is trying to establish a connection and is not establishing connection. This is called retransmission. So there is a big difference between the retransmission and reset. So retransmission is, it is trying to establish a connection. It is not resetting the connection. It is not at all ready to send a SYN-ACK back now. But you see the three-way handshake and there is a reset happening because it resets the connection. I don't want to continue a connection, but there is a connectivity end-to-end connection between source and destination. But retransmission is something it is trying to reach and it cannot reach, then again it is sending the connection back. if you see this, this packet is not routed. How do I say that? If you click on this particular packet, and if you go to the TTL, it says 128. It is not decremented, right? So the packet is not even routed. It's not even pushed out of my device, right? It is just be here because it's not routed. So I see the TTL is not decrementing. So whenever I see a TTL is decrementing, there is definitely a routing. This is a problem with layer 4, but this is a problem with a routing because the packet is not routed out. It didn't go out of my device, right? So this is the IPerf. This is a tool we use to do this testing. So now let's see what is the latency. How do I find a latency using a TCP? So I'm going to use the same IPerf connection. So I'm going to capture the traffic again. So when I have a successful connection to it, so I have a successful connection. Let me break the connection and I'll continue my capture. So you can see a lot of traffic going in here. You can see the packets, a lot of packets going in here because I'm pushing a lot of packets from IPerf, my command prompt. So the IPerf has been completed. I'm going to stop this capture. I'm going to the top of my Wireshark here. So you can see the all this destination traffic, destination IP is same. I mean, this is all the traffic it's coming back from the server back to me. So I did a 10 parallel connection for this to simulate the traffic. So how do I find a network round trip time? How do I find the latency in a network? I'll take one packet here. I'll do a right click. I'll go to conversation filter and I'll do a TCP. So let me take this packet, conversation filter, TCP. So I want to see the complete three-way handshake to understand my latency in the network. Let me go to this packet, conversation filter TCP. I'll try one more time because I want to capture the three-way handshake. I think I didn't do it quickly. So the IPerf is done. I'm going to stop this. I can see if in packet I should see my handshake. Somehow I'm missing the sequence. I'll try one more time. Yeah, now it is connected. Let's stop here. Okay, so I got it here. So syn synac ACK between the same source and destination, right? See, I see the three-way handshake here. Syn synac ACK. So how do I find the network round trip time? So you can check this. See, the retransmission is happening. So this is in seconds. This is in milliseconds. The first octet here. This is in seconds. and this part is in milliseconds. So the retransmission is happening after 7 seconds. It took 7 seconds for this retransmission for the final packet. So for this, it took 291 milliseconds. The third packet, if you see, it took 1 second. It was waiting for a second to do a retransmission. So there is something called as a TCP retransmission timer, called a TCP timer. It will not do the retransmission directly. Example, I have sent a packet. The packet 1 has been sent here, this packet, the first retransmission here, and it is actually waiting for 561 milliseconds. After that, it's going to send the second packet back, but still it can't reach it. So it is waiting for almost like a 1 second, and it sends the third packet. So this is a TCP timer. So when we come to the network round trip time, the first packet when I sent, you can see this, it starts with 0, right? So after exactly 166 millisecond, I got a reply back from this destination, 51.158.1.21. That is our iPerf server. So the network round trip time is within 166 milliseconds, I got a response back from it. What if this jumps to 7 seconds? Imagine here in the second row, you see the timing as 7 seconds for this particular packet. The SYNAC took 7 seconds instead of 166 milliseconds. That is for the highest latency in your network, right? So right away you can go and find, okay, there is something problem with my transport. I have to check something with my WAN connection. There is something problem with the network. So this is called network latency. So when we talk about the application latency in the classes, we will see when you establish your HTTP connection. If I see that there is a problem with my HTTP connection, the latency is high, or it is a network, because this is the most wide debate happens between the application team and the network team, right? So they say it's a problem with you, it's a problem with the network. So we say it's a problem with your application, but how do we prove that? We can say, see, my latency is just 166 millisecond. I can get a response back from your server. But if you see something like 7 seconds, you can say that, so I send a packet, but I had to wait 7 seconds for the server to respond back to me. Imagine this 7 is here, second packet. So that's how you're going to figure out how this latency, how do I find the network latency? This is called as a network round trip time. Why it is called as a round trip time? Because the first SYN packet, when it's sent here, it starts with 0 second, right? It starts with 0 second. So I send a packet. This is packet 1, right? Starts with 0 second. This is my SYN packet in my TCP. So after 166 milliseconds, I got a response back from the server, SYNAC. This is my server, and this is my client, right? So this is your network round trip time. So you can say this is how you can find your network latency. So the same way, this is called as an expert warning information. This is called expert information. So this will give the complete insight. So when we want to see the huge amount of traffic and you want to figure out a problem, is it a lot of reset happening? No, it is just one reset. Why? I am looking for only one connection. This is one stream of connection. So if I remove this filter and if I go and hit the same button icon here, there's a whole summary, right? So if I go ahead and see how many resets, there are a lot of resets. But if I'm interested to see the one specific reset for a specific port and destination, I have to click on it, right click, apply as a filter, selected will give me the information only related to that particular stream of connection. And by looking at this, I can see the TCP segment length is 0. There is no packet is being sent because all these are reset packets, isn't it? You can't see any packets being sent or received between the source and destination because it's purely a reset packet. Until this point, there is no TCP communication is happening. It is just a three-way handshake happened and it resets the connection. So there is a successful connection, there is a routing, but there is a reset. There is no actual traffic has been exchanged between the source and destination. So that is how you have to apply your logics and you have to figure out where the problem is. So now coming back to the Nmap, as I said, we will do one more simulation for Nmap and then I'll explain what we are going to do with the Nmap. So you have been given with a scenario example, you want to find a duplicate IP address in your segment. They are using a duplicate IP address in your segment, right? But you want to know what kind of device is that. So let me show you what Nmap looks like and how we are going to use an Nmap for it. So here is you can run your commands, Nmap command. So what I'm going to do here, so to my Wi-Fi modem, I'm going to send a probe using an Nmap. So if you look at this, my default gateway is 192.168.0.1. So I'm going to discover what kind of operating system is this. So I'm going to run this command. So what it says, this is nmap and this is my destination and this is my operating system discovery. -O stands for operating system discovery. Yeah. So I'm going to tweak this command to my gateway is 192.168.0.1. And simultaneously, you're going to see if what if somebody is doing a scan, somebody is doing some scanning in your network, how you can find using the Wireshark, right? So I'm going to stop this capture again. So when I do this, I'll start the capture and I'll show you. So this is a command nmap and this is the destination and do a OS discovery is something I said. And I'm going to scan it and simultaneously I'm going to run the Wireshark parallelly here. So I'm going to scan this. Let me open the Wireshark here. We stop the capture. So you can see the open ports. So what I did is just an OS discovery. You just see how Nmap is doing other scans. So use this carefully, use this only in your lab and get a proper permissions or approvals when you're doing this. Don't test this in your enterprise. You get a proper approval and do that. So it is telling that this is a Linux operating system. This is a OS details. This is a Linux operating system and this is some MAC address of it and you can see all the open ports here. The host is up and the latency is 13 milliseconds. Everything in millisecond and this is the destination. So there are 995 closed TCP ports. They sent all of reset packets back. Now I am going to the Wireshark. So I am going to give this IP address because I am interested in this IP address traffic. I am going to just filter this IP. I don't want all the traffic here. So what I'm going to do, I'm going to type IP.address equal, and this is the destination IP address. If I give this, just look at it, how many resets and how many TCP scan request has been sent from my computer to this destination. If you click on this export info, You can see, open this, you can see the number of reset packets here. Look at this. So this is not good. If somebody is doing a scan, you should figure out, is it not the legitimate scan, right? Because this is an unwanted information, what Nmap is doing it and how Wireshark is helping you to find it. Just see, I'm just trying to figure out only the OS detail. It has sent about 2062 packets. You just see why it has to do a TCP SYN scan for it. So this is a security problem, right? So you have to figure out. So anyway, this is going to reset all your connection back. There is, if you see, there is no packets being exchanged. That is how you should see here. You see this TCP segment length. See this TCP segment length, all are zeros because no packets has been exchanged. I mean, no data has been exchanged. And you just look at it. This is all the number of scans it does for different ports. So this is my same source going to the destination, send a SYN packet for DNS port 53, port 80, 445, 256. So why it is doing all this? But if you use this for your troubleshooting, with a combination of Nmap and this, you can figure out when there is some duplicate IPs coming up. Sorry, when you see your duplicate IP address on your screen, you can figure out, okay, I know which host is doing that. Maybe you might have your firewall, it says it is a Palo Alto. If it is a Cisco, it can say Cisco. So you will get a better, direction. Okay, I have to go with the network devices or security devices, or it is just one host is doing all this SYN. And I was talking about the layer 2. What is the layer 2 is more important here. So if you look at this, what is the destination? The destination says it's a TP link. It's my modem. If it is a firewall, it's going to tell you it's a Palo Alto. It's a 40 gate. Just with the MAC address OUI, the Wireshark is going to give you the name of it. So this is how it works. And as I said, this is how we are going to learn for every topic. We are going to stick to the Wireshark and we are going to do the practical 80%. And side by side, we are going to do a whiteboard. So not a theory session. Get your hands dirty with your practical. And this is a whole course is about. So now let me unmute everyone. So there's a Q&A session. You can ask your questions now.
Hey, Praveen, I've got a query.
Yeah. Hi, Marcus. Yeah.
Hi. Hey, the latency stuff, what you were trying to explain, right? I have a scenario like wherein my application was working on 80 milliseconds round trip, and due to a network choke in one of the WAN router, right? That latency is increased to into 10 times. Assume it is 800 milliseconds now. Now, in those scenarios, how do we is there any what I mean? How can this scenario be tested in this?
No, as I said, if you remember, where do you see the latency? I mean, the round trip time. Whose latency is high? You said is it the destination IP is what destination IP is your WAN IP is showing the spike?
No. Assume I've captured from my client. I mean, the client is trying to negotiate with the server, right?
Okay.
And now if I take a capture, it is showing me that the RTT is all working fine. Like, I mean, there's no there is no reset flag or anything. But the round trip millisecond, when I see it showing us at 0.8, which is like 800 milliseconds.
No,
still
my question is, I mean, you see that 800 milliseconds whatsoever, but where you see that? I mean, have you checked in the Wireshark or something? You found
it's in Wireshark, like whatever you're explaining, the three-way handshake, right?
Okay.
From the client to the server and server back to the client. And the client back to the server. So all the three-way handshake happens, the layer 4, layer 7, HTTP traffic, everything happens.
Okay.
But if everything is happening on 0.8 milliseconds on an average. but still the application is trying to complain that my application is still slow. Basically, why it is slow is because the application is so sensitive that they work less than 100 milliseconds only, right? But
Is
as per
it,
my, yeah,
but is it something, have you verified your latency in your HTTP packet, or it is just your TCP
no,
three-way
on
handshake?
the, I'm talking about the TCP handshake itself.
Mm-hmm.
The TCP handshake itself is showing me 800 milliseconds, right? Uh, the TCP itself
Okay,
is 800 milliseconds.
800 millisecond is not very slow. Actually, it's fine. I mean, up to
No,
one
no,
second is
yeah.
okay.
I mean, so according to the normal network terminologies, assuming 800 millisecond is not a problem, it's all fine. But just assume this is like having only like a 3 or 4 hops. I'm just trying to put a like a scenario which had a practical scenario, wherein it was 3 or 4 hops, but this application is quite time sensitive,
Mm.
and it works only with a response time of 100 milliseconds. Anything more than that, it has a problem, right? But we
Uh,
don't have that the sensitivity of the application, right? So is there any way that we can try to figure this out until unless we don't know the previous working scenario of this application, which worked in 100 ms? Some kind of this scenarios. Is there any way, or I'm just trying to.
you can just open the, you can use your computer to open the same application, and you can observe the latency, and you can compare with the other web server. And if you see it is normal, then it's a problem with it. They have to tweak something with the application, isn't it? I mean, or else you have to increase your bandwidth to satisfy your 100
Yeah,
milliseconds.
agreed. But here, in the sense, unless we don't know the standard working, the standard working, whatever the sensitive milliseconds of the application, will not be able to. I mean, unless and until. I mean, if it's like
No,
more than
you
70
can.
seconds, we
No,
know.
I got you, but the whole
Uh,
point is you can prove. I mean, the see for other applications, so this is the latency it works, and for your application, it is slow because it's something they have to do something for it, right? Because
No,
if
no, no.
that
What
is
I'm trying to say is this was all working. I mean, what I was saying is that it was all working fine, 180 ms, which was a normal scenario. But due
okay,
to a choke in one of the bandwidth, this increased into 10 times. It's increased into 800 milliseconds. Now,
but
for yeah,
if it is a 4 hops, you said you do a trace route and figure out on every hop what is the latency in the network.
yeah,
So
exactly. So at this time, then you have to see the trace route
hop by
and see
hop,
where exactly, yeah,
yeah,
hop by
where
hop
the
and
spike,
see
hop by hop, yeah.
where this pops
And
increases.
yeah,
Yeah.
yeah, and also you can see that in Wireshark for every, for because if you know the trace route how it works, for
Mm.
every trace route there will be a what is that time exceeded messages you will get back to the source, right? So for by
Mhm.
comparing it, you can figure out what is the latency in a hop.
No, so that's what my point was. Assume I'm not doing a trace route. I'm assuming, is there any way in the Wireshark itself we can figure it out, like which have
No,
opt?
no, you have to know. You have to do a trace route in your command line, and you can use the Wireshark output to compare the timings. What is for per hop? What is the time taken?
Okay, okay, but you need to have a comparison. There is no way in Wireshark it will show the multi-hops results.
No, it will show, but I am telling you have to simulate the traffic in the background. I mean, it will not do it on its own. I am telling you have
No, no.
to go
What
ahead
I'm
and do
asking
that.
is, Praveen, so for example, the three-way handshake, right? The
Hmm.
first handshake, whatever millisecond it says, is from the client to the server, not hop by
Yeah.
hop.
No, no, no. See, that's a big difference. Let's see.
Mm.
The TCP is a peer-to-peer connection. So you
Right.
can't see what is happening in the middle. But if you want to see every hop latency, then you have to do a trace route.
Trace route only, right? Yeah,
Yeah,
yeah.
yeah, yeah.
Okay, okay, got it.
Yeah, Emmanuel. I'll go one by one. Hi, Emmanuel. I give. Yeah, you have an unmute permission. What's your question? Okay. Hi, Rishvi.
Hello.
Yeah.
I have a question. Are we also going to read how to read R files?
Can you hear
Well,
me?
Yeah, I can hear you. I'll come back to you, Emmanuel. I mean, Rishi is talking. Yeah, you are the next. Yeah. Yeah, tell me, Rishvi.
Yeah, I was asking, are we also going to read HAR files? HAR, Fiddler
Uh,
tool,
I don't know about har files, Rishvi. What is that?
So,
Har files?
Rizvi, actually, this part we will not cover here generally. Okay. So, like here, we will totally focus on the Wireshark. We will not include anything with regards to Fiddler and all. So, this R file basically we use to analyze when there is slowness at your web applications. Praveen.
Okay. No, we are not going to cover that, Rishvi.
Okay. And what exactly are we going to cover in HTTP while we were learning it? Is it going
No,
to be
more,
how to read
more,
like
mostly the HTTP latency. We will see HTTP and HTTPS latency. What is the
the
time
protocol
taken?
behavior
Yeah,
itself
protocol.
as
Yeah,
well, like
yeah,
the response, the get response,
yeah.
those.
Example, if your TCP communication is fine, if you don't see the network latency in your TCP, so apparently there should be a problem with your HTTP. Is it the client or server is slow when we're doing this HTTP troubleshooting using Wireshark when we simulate?
Okay. So in other words, what we are going to learn is more about the troubleshooting or understanding of from layer 1 to layer 3, not
Layer
specifically
7.
from layer 4 to layer 7.
No, we'll cover the layer 7 also, up to layer 7.
Okay.
Yeah, we cover from layer 1 to layer 7 because we have a separate topic for SSL. We have a topic for
Okay.
HTTP. We have a topic for DNS.
Okay. All right. Thank you.
Yeah, thanks, Rishi. Yeah, Emmanuel.
Okay, all right. Thank you. Yeah, I was also just gonna ask a similar question because I joined late. So
Yeah.
I wanted to just ask about the maybe kind of course content, and then I noticed the session is being recorded. Then, okay, can one get access to the recording session as well too? So that in case I have peculiar or unique aspects that I'm looking forward to getting trashed in this class, I could actually like ask my question of my expectation regarding that. So I think it's good that someone has asked that what aspect of layers or TCP IP layer are we covering? Is it layer 1 to 3 or the entire layer 1 to 7? So but it's okay that you've mentioned that the sessions will cover layer 1 to 7 troubleshooting. So it's all right.
I mean, the question is, I mean, you're telling this session is mostly focused on troubleshooting. Is that your question?
Yes.
Obviously, it's not only the troubleshooting, you will also understand the protocols, right? If we learn protocols along with the troubleshooting, I would say.
Oh, okay. It's all right.
No problem. Thank you, Emmanuel. So, is there any other questions, guys?
Praveen, what is the schedule of these classes? Like, how many hours per day and what days?
It's a 2 hours per session. It's close to 40 to 45 hours. It will take 40 to 45 hours to complete the
Okay.
training.
And which days and what timing is it?
It's morning 10 to 12, and it's a
Praveen, this
weekend
one
batch.
we can install that software in our own laptop to get the lab
Guys,
access
ask the question
regarding
one by
that.
one.
So
Radha,
Yeah.
can you
it mean
just ask your
there is
questions later?
we need to
Radha,
install in our own laptop and to do the live troubleshoot, right?
Radha, 1 minute. I'll come
Like
back to you.
simulation.
I'll come back to you. Can you hear me, Radha? I mean, I'll come back to you. Actually, there was a guy, he was asking a question. Yeah, I'll come back to you about your questions. Yeah. Just wait for a second, yeah? Yeah, Marcus, you said,
Yeah,
what is
Praveen,
that?
sorry. So it was
Yeah,
10 to 12, Saturday, Sundays, both days.
Hello?
yeah. 10 to 12 Saturday, Sunday morning batch, yeah.
So it's 10 to 12 Saturday, Sunday. So it'll be like 4 hours per week. Yeah. So it'll be almost
Yeah.
like a 10 weeks session. Is it?
Yeah, 2.5 months. Close to
2.5.
2.5 months, yeah.
Okay. Thanks.
Yeah, Radha, you ask your question. What is your question?
I mean, for lab access, like lab mean which we are installing that simulation, installing our own laptop to do the live troubleshoot in through simulation, right?
Yeah. It's a
Okay.
combination of both. Sometimes we will use only Nmap and Wireshark, but
Okay.
only maximum maybe 4-5 devices we may use. One
You
Palo
will
Alto
provide
and
that
5.
OVA file, that file which need to be installed in our map it on that VM and like
Yeah. We'll give the
okay,
link to download. Yeah.
okay, and then this also like 2 hours weekend batch and
Yeah. Correct. 2 hours
2 hours
weekend batch.
each.
Yeah.
Okay.
Correct. Any other questions, guys?
Yeah, when it starts from next week, is it? Like when does it start from?
No. I don't think we are starting next week. Maybe you can reach out to Muskan.
Okay, fine.
Yeah.
And even the course content, we'll get it from Muskan, right? Whatever you're sharing.
Yeah. Correct. Yes.
Okay.
Sorry, could you please repeat? The first class would be tomorrow or
No.
next week?
No. Not next week. We'll be starting soon, but the
So,
date the
let
Muskan
me
will
let
let
me
you
add
know.
here. So this training we will start from 6th of December. So like first week of December. Timing is 10 a.m. to 12 p.m. IST in the morning.
Yeah. Correct.
Okay, thank you.
Trivin, you can just bring that banner actually if you have.
Yeah.
Share your
Okay.
screen so they can write down our numbers so
Yeah.
they
Sure.
can reach out to us.
Sure. Hemo. Yeah. I don't. Is it sorry, Hema. I mean, I don't have an access for WhatsApp on my computer. Is it Mushkan can help me with that?
Not an issue then. You can just mention my number.
The number, yeah. Okay.
Yeah, just mention my number so they can reach out to me.
Can call this number 9. You guys can see my screen?
You have
Not
not
yet.
shared actually.
Okay. Let me make it a little bigger. Yeah, you can call to this number. Also, I'll give you one more number. You so you can call to either of these numbers.
Anyone have any other questions, guys? You can ask, otherwise we can close this call.
Praveen, I have a query. So
Yeah.
you mentioned that you will also explain the SSL. So which means like an SSL as well as the all the protocols. So you will explain the theory of each protocol and as well as the troubleshooting of those protocol in the Wireshark, right?
Yeah. For all
And
the topics we discuss the theory as well as troubleshooting and the concepts. Yeah.
so it's a Wireshark course, right? So if you could explain, like if I talk about the SSL,
Hmm.
so how will you explain SSL in terms of Wireshark or the troubleshooting? So you will explain all these steps, how we
Yeah,
will.
exactly. I mean, what is the use of encryption there, and what are the protocols used? What is uh, what is that? What is the key encryption hash used, and how we can going to decrypt it, and how this SSL connection establishment happens, and if there is a connection issue, how do I find? Then what? How do I use a record layer to figure out where the problem with the certificate? Just
Okay,
like that.
so like will you show or explain us how we can explain SSL handshake in Wireshark? What
Yeah,
all are the
you
steps
parameters, everything, packet by packet. Yeah. And what is the
on the
difference
Wireshark
between
only, right?
no, what is the difference between TLS 1.2, 1.3? How the messages are different. It's like that. It's a protocol. Whatever we are learning, we will see that packets in the Wireshark. That is the difference.
Okay.
I mean, is that your question is we will be just discussing only from the Wireshark perspective, or we are going to learn the protocol and Wireshark together, right?
Yeah, both.
Yeah, we are learning both.
Mm.
Praveen, there was one question about the lab. Just want to reconfirm. Will we get a virtual lab or is it like our own
No, this
lab?
is your own lab. This is, as I said, you need a 16 GB RAM. Your computer would be sufficient for this.
Okay, you need a 16 RAM,
GB
is it?
RAM, yeah. When
Okay,
you have
and
at times you have to run your Palo Alto with couple of routers.
okay. So you will like we need to set up our own lab, and you will tell us how to do it. Yeah.
Yeah, correct. We'll give the steps and procedures to build your lab.
Okay, and what is the application we used for this lab?
EVNG, Nmap, and Wireshark.
Okay, so all this three needs to be installed in my laptop. Yeah.
Yeah, correct.
Okay.
And guys, we will also share all the necessary softwares, all the over images which you needed to build that lab. And that lab setup will be carried out in your sessions, and Praveen will also help you if you will stuck anywhere during the lab setup.
Yeah.
Because sometimes you might need a license for the Palo Alto and all, right? So how about all that?
So for those practicals, license is not needed. Whatever we need to do for this Wireshark training, license is not needed. Without license, we can able to practice 75% practicals in Palo Alto.
Okay, so you don't need
Not required. Yes. Okay, so guys, we will done with the discussion with today. You can take the screenshot of those numbers. You can reach out to us if you are interested for this training. Take care, everyone. Muskan,
Yeah.
you can just close this call now.
Thanks everyone. Thanks Hemu. Thanks everybody. Bye.